Okay, cool. And so we are going to talk about NumPy. And NumPy is going to be basically like our big package, our library to use a lot of the functionality of like doing some more numerical calculations with Python. So you can think NumPy, numbers, Python. It's kind of a play on words on that way. And there's a few things kind of cool about NumPy in general is that NumPy also is, what's it called? Pandas. So we've been using Pandas before. Pandas is actually based around NumPy. So like you'll see the way we do stuff in NumPy, and even some of the functions that we actually write in NumPy are literally like the same things from Pandas. And the reason why is because literally Pandas is using NumPy as kind of a support. So it's kind of like scaffolding. So if remember talking about we do inheritance for what's it called? I'm trying to think. Inheritance from like object-oriented programming. That's kind of what we're doing. Pandas is inheriting some functionality from NumPy. So that's actually why we're able to use these certain things. And you'll see the similarities as we go through. So big thing I would say is that NumPy is big for, it's really big for anything with machine learning because you have big data sets. NumPy has some really cool features in the way of something called vectorization. And so we kind of been using something called like lists and stuff like that with Python. And using a list in Python, we can put whatever we want in it. We can put a string, we can put a number, we can put a function, we can put a list within a list. You guys probably saw from the shopping cart thing, we can put dictionaries within lists, we can put all these different things. NumPy, when we start doing something very similar called an array, you'll find out that we can only do very specific items. So you can only put integers, you can only put these floats. So basically it kind of defines it ahead of time. And one of the reasons why is basically for efficiency. So NumPy actually has a lot of really cool efficiency and uses something called vectorization. And the only way you can do those kind of things is because you have the way it's structured within like, how do I say this, in memory in the code itself. Basically it comes down to Python is built on top of C++ programming. And basically it allows you, NumPy basically takes advantage of that so you don't have to worry about where things are stored, and it can make it much quicker. So what we'll see a lot is I'll say something like, oh, do a vectorized form over a for loop. So for loops in Python tend to be much slower than vectorization forms. And we'll talk about what this is as we get deeper and deeper into using this stuff. But that's one of the reasons why we'll see NumPy a lot for machine learning, because a lot of times the machine learning is basically just math, and we want to apply this math as quick as possible, efficiently as possible. That way we're not taking as much memory, and also it does take forever for us to do predictions with machine learning. And again, machine learning will be something we'll do in the future, not far future, but like in our future. Okay, so I'm going to go ahead and start sharing my screen. So I can't find my screen. There it is. Oh, that's the wrong screen. I don't know what I'm sharing. Sorry, guys. It's been a long day. I think I talked to some of you guys already about this. So it's just kind of, it's starting to show more and more. Okay, share my screen. And where are you? What are you? Oh, I have too many windows, guys. But okay, so just kind of while I'm trying to find my screen, this should be it. Why isn't it? Can you guys see? Okay, intro to NumPy. And I lost you guys now. Okay, so maybe I didn't share the right screen then. It disappeared off a weird, you can't see this, but my computer did something weird. It moved all the windows around. I can't find them. Okay, so NumPy, all right? So the simple way to import it, it's a package. We're going to import NumPy. And note that the convention usually is NP. That way we don't have to write NumPy every single time we want to use the package. That's pretty standard. Just like we did import pandas, we import with PD, okay? So I'm just kind of importing these together, okay? And wait a second, is this right? Sorry, guys. Okay, good. I got concerned I did something wrong. So, okay, so the first thing we want to talk about for NumPy is using something called an array. So you'll see here is that it looks very similar to a list. In fact, we're using a list. And this is going to be particularly useful when we do some calculations. And you can kind of think of like a NumPy array as essentially just a Python list, but it acts differently underneath there. So one thing you can't do is you can't put whatever type you want in a NumPy array. Another thing too is that it turns out to be very, very quick and very efficient at doing any calculations and stuff like that. So I'll show you what this is right here. So I'll put my NumPy array, and this basically creates this NumPy array. You can see it says array 1, 2, 3, 4. One thing you should note is that I don't know if I made this really explicit, but when you have the last line right here, for example, if I have like the number 1, oops, that's not 1, number 1, you see how it displays this part right here. Okay, this is basically at the very end of a Jupyter Notebook cell. It actually calls a function called display, and it basically is literally just doing this. It's saying, oh, that last line, let me go put display around it, and it runs that part. Compared to print, which you can't really tell the difference in this case, but there's a subtle difference in certain elements. So for example, when I do like my array, which is a NumPy array, you'll see it prints out like this. If I do a print my array, it'll look different. So just know that there's a difference between print and display. So if I do a print right here versus I do display my array, okay, you'll see that they come out differently. So if you print out a NumPy array, it'll default to basically looking like this. If you do a display, which is at the bottom of a Jupyter Notebook cell, it'll actually call this part here. So know there's a slight difference. So you can also tell that this is not a list because there's no commas. So just to kind of prove you guys, if I do print 1, 2, 3, 4, you can see that there are commas in here versus not in here. So that's kind of your clue saying, oh, that's a NumPy array. Okay, but I wanted to show you guys that difference. Okay, not that it was super important, just that there is a difference. Okay, so that's our NumPy array right here. Okay, and so with this guy right here, we can actually do very similar stuff as we can with a list. So right here we have, I'm going to create a list over here. If you remember using a range 10, that'll create a list of 10 elements starting from 0, 0, 1, 2, 3, 4, 5, all the way through 10, or all the way through 9. And I can create a NumPy array using that range. Okay, you can also do the same thing with tuples. So you can see here, there's now my NumPy array. And you can notice that it's a NumPy array because I used that print and there's no commas in there. Okay, I can do a similar thing with tuples. So if I instead pass a tuple into array, into a NumPy array, it'll create a NumPy array. Okay, so kind of like straightforward. And then, sorry, I didn't know what happened there. With a series, so this is a pandas series, you remember how we could do this right here? We can actually create a series with a list. This is actually the same thing as an array, essentially, but we can pass a series into a NumPy array. So basically, NumPy arrays can take a lot of different things to form it into a NumPy array. And once we have that NumPy array, and I'll just call it arrays from now on because it's tired to say NumPy every single time, but just know every time we have these arrays now, you can do all the functionality with it. And kind of fun fact is that series for pandas is actually a NumPy array. It's actually using a NumPy array for a series. So that's kind of like why we can use that functionality. Okay, any questions about implementing this first part? This should be, again, starting off pretty slow here, right? Saying, all right, if you pass in something that's list-like, you'll see that in the documentation. If it's list-like, you can go ahead and pass it into this array part right here, and it'll create a NumPy array. Okay, so this comes up cool. We got a new little function or a little thing called an array. What can we do? So one thing we can do is we can look at how lists work. So this is a good comparison, like why we can use arrays versus a list. So an array here, or sorry, in a list here, I just have a normal Python list. Can I add 4 to it? If I have a list of 1, 2, 3, 4, and I add 4, will this work? Not sure. Well, let's try it out, right? Doesn't like it. Basically, it says, hey, you can't do that. You can't add just the number 4 to a list. If you can, however, do a plus another list. So we can add lists together. So for example, if I have a list 0, which is 1, 2, 3, I can add another list 4. For example, I could also put 5, 6, and this will add on to that list over there. So we can add lists together, but it has to be a list in a list. Okay. So note that I can't add the number 4, but I could add like the list of 4 in here. Okay. Depending on what you thought here, you might think, hey, could I just add 4 to each one? In this case, no, you can't do it. And we'll see there's a difference in NumPy. And then can we do a multiplication? This is kind of fun. So can we multiply lists by 3? Thumbs up if you think so, thumbs down if you're like, nah, it's gonna give an error. Let you guys think a little bit. Okay, so mostly thumbs down. Some people not wanting to show their thumbs up, thumbs down. I see Thomas like, I'm not sure about that, right? I see maybe sideways, down, okay? So first of all, no one put thumbs up, which, I mean, if let's say someone did put thumbs up, what do you think they would think would happen if I multiplied this list 1, 2, 3 times 3? What do you think they would think happens? If you knew nothing about Python, you said, oh, I have a list and I multiply by 3, what do you think would happen?
Maybe it'd make each element of the list multiply that by 3.
Okay, cool.
3, 6, 9.
And so yeah, so you say 1 times 3, 3, and then you might have like, 6 and then 9, something like that. I think Hazel, I saw you do that. Was that what you were thinking too? Okay, cool. So yeah, that's probably what I would think too. I would say, oh, it's probably multiplying each part by 3. So it turns out it does work, but it doesn't do what you think it is. It basically makes 3 copies of that list. Okay, so kind of interesting thing. You can basically create a list now. It's saying, oh, just repeat the list 3 times, which kind of makes sense, but also, I don't know about you guys, I'm like, oh, I would not have expected that if I didn't know Python. So some differences in lists. So quick thing, do you think you can divide by 3 for a list, knowing that we see multiplication? Short answer, no, we can't do anything, okay? So division, multiplication does work, but not in the way you expect. Division definitely doesn't work, okay? And of course, like I said before, we can add lists together. So if you can see this list added together, but just appends it. So you notice that when we're doing methods on a list, it's not really changing the elements. It's more like it's changing the actual list itself. Okay, we're adding onto lists, making copies of lists and putting it together. We're not changing the elements in the list. So NumPy arrays, we'll see, is actually more number focused. So right here, I'll make a NumPy array of 4 elements from 0, 1, 2, 3. Okay, and I can actually do all this math. So you'll see here, I'm also gonna do a +3, and I'll tell you right now, these all work. But you can do a +3, -3, multiply by 3, divide by 3. So what each of these will do, if anyone's got a guess, kind of leading it up to this point, but what each of these things will do will actually broadcast it onto each part. So kind of like what Andrew had said with the 3 multiplied by 3, it'll actually do it to each element. So you can see if I add 3 to each one, it adds up 3, subtracts 3, multiplies by 3, divides each element by 3. So kind of nice, like, okay, that's kind of like what you'd expect probably if you didn't know anything about Python, you probably would expect this would be. So it's really useful for us to do this stuff, okay? We can also add lists together. So this one's a really interesting one. So remember last time we created these, I'll show you guys just to show you what they look like, right? I have these 2 different lists, or not lists, these 2 different NumPy arrays, these 2 different arrays. And last time when we added the lists together, it just put it together, like just stuck them together, glued them. But in this case, when we add NumPy arrays, it'll actually add up each element. So 0 + 3, 1 + 4, 2 + 5. So basically each element in that list will be added up together. So this is really useful because this will treat very similar to what we'll find as a vector. But basically, if you're familiar with any of those terms, essentially what we're doing is adding up vectors. And this is super nice because we'll do a lot of math where versus in a list right here, we'd have to like do some list comprehension or do a for loop or do something just to make this work, okay? So any questions about anything of the math stuff I showed with how NumPy works?
Maybe you'll get to this, but what happens if you're adding an array with different number of elements?
Okay, yeah, let's just try it out real quick. So let's say we have a list with like another extra element. So let's put like number 6 here. So you can see there's a little extra number here. And we try adding it together. What do you guys, any predictions of what might happen? I think these are just predictions. You don't have to be right.
It's going to be 6. It's just going to add 6 to it.
Maybe just have the 6 at the very end. So maybe it's like 3, 5, 7, and then just like 6, right? Well, that's a good guess, right? Let's try it out. It doesn't work. So one thing it says right here, you'll see value error. Operands could not be broadcast together with shapes 3, 4. Basically, it's that it has to have the same number of elements. There are certain things you can do, and we'll talk about this actually in module 2, where we talk about how we can do advanced moves like broadcasting with NumPy arrays. But there are certain situations where NumPy is pretty smart and says, hey, I think I know what you're trying to do, so I'm going to try it. I'm going to try to do it this way, kind of in the same way where we can add like the number 3 here to this array. There's certain ways we can do like add, for example, if you have like a NumPy array of arrays, you can start doing certain things with it, but we won't talk about that today. Okay. But yeah, Andrew, we will talk about it, but like future, definitely, like not today, just so you know. So this kind of leads us into multidimensional. And so a multidimensional array, okay, is basically an array of arrays, okay? So I'm gonna kind of slow this down a little bit from like what I had originally planned. So if you imagine we can have like a list of lists, right? So you kind of see this structure, right? I have a single list here. I'll just call this like A. Oops. Okay, I have a single list here, and I should actually print it out, okay? And this single list contains in each part a list, okay? So I can see here, I can have one single list which has all these elements, and then the very first element in here is this first list. So if I did like let me just make a new one, A0, that will give me the first element of this big old list here. And what would be the first element in this list? Well, it would be this very first part. So it would actually give me the list of 0, 1, 2. You can see that's my first list. Okay, does that make sense? So, another way I can see this too, just kind of going forward, let's say like A, oops, this. So, and then I'm trying to do this on the fly a little bit. So I have all these different, I have all these 3 different lists, and then this big A right here, I could have something like, oh, it's A1, A2, A3, all right? So you can see here now, if I try to doing the letter A now, you can see that's the same idea. That's essentially what's going on here. It's like, oh, when I get the first element, I'm getting A1, which is just this guy right here. So I get A0, and that, okay? So just kind of know that's kind of the idea of like having a multi-dimension, right? So we have list of lists, okay? And obviously, if we want to do more, we can go even deeper. We can do a list of lists, which also have lists within it. And then there's no reason to stop at 3. You could have a list of list of list of list of list, you know, where it's like 5 dimensions deep, okay? So this is kind of like what we're getting into, saying, okay, like how can we structure this? So NumPy actually allows you to make these kind of arrays too. So you can see here we have a list of lists, and that will create basically another array, and this array will actually be kind of similar to what before. Now note that when I have this list like this, by default, it just shows you the long list of things with these parts right here. NumPy is kind of a little smarter, saying, hey, like you probably want this to look like a list of lists. So you can see here, here's my big old array, and here's my first array. So each part of these are actually its array itself, okay? So this is how we can create what we call like multi-dimensional arrays. So in this case, you can actually think of it as like 2 dimensions, okay? So like you can kind of think like, okay, this is our first one. It's 2-dimensional where we can see you have like an X and a Y. So like your rows and your columns, okay? And next we have is a 3D array. So you can see here, I got really fancy. So this range right here, if you remember, if I run just this part, just to kind of show you guys what this works out as, I can do a range, and this is basically, oh, well, that doesn't help you. Let's just do a list so you can see what it looks like. So you can see like a range from 0 to 3 will go from 0, 1, 2. So a range from 3 to 6, range 3, 6, that will create an array starting at the number 3, and then 4, 5, and stop there. Okay, so basically it ranges from 3 to 6, stopping at the 5th one. Okay, so this is what I'm doing right here, is basically making a bunch of little, a bunch of little lists right here. So I have a list here, and then this whole thing is contained in one list, okay? So this is already a list of lists, okay? And then in here, I'm basically saying, oh, well, each of these are a list of lists. And so basically this whole thing right here is a list of lists of lists, okay? So you can see it's getting pretty deep now. And when we print this out now, we call this a 3-dimensional shape. So you can see if I run this, you can see it's kind of structured in a different way. So you can almost look at this, like if you look at this very first bracket, this very first one, it's essentially saying all of this stuff right here is in that one bracket, in that one array. And then inside that array, I have another array, okay, which is basically a bunch of arrays. So you can see this right here. This structure right here is the same as this guy. You see that? So you can see like, oh, I have a 2D array, I call it a 2D array. And this first element of this 3-dimensional array is a 2D array, okay? And the first element of the 2D array is in this case, we'll call it a 1D array, all right? So you can see this are the different elements in here, okay? Any questions about what I'm showing for this 2D versus a 3D versus, you know, the very first time? Cool, thumbs up if you're feeling good. Thumbs down, you're like, I don't know. Sideways, you're like, yeah, maybe stare a little bit longer. Okay, yeah. So I saw maybe a couple sideways like this. Yeah, this is definitely something we'll talk about more and more about, but just kind of know is that data science, I almost feel like we should talk about like dimensional science, because I feel like everything we talk about with data science is really about essentially stacking these things on top of each other. So just know that there's no stopping. I could then take this array, for example, and make a 4D array where each element in that array is a 3D array. And each element in those 3D arrays are a 2D array. And each thing in those 2D arrays are a single array. And each thing in those single arrays are just numbers. So that's kind of like how you go deeper and deeper into these parts. Okay. And we'll talk about this more too, especially in Mod 2, when we start looking at more machine learning algorithms. And basically machine learning algorithms and a lot of our analysis will be based around multiple dimension like this. Okay. But now that we have this, like, okay, cool. I have this 3D array and this part. We have something that's called this shape that's built into arrays. So I will show you, let me just show you one, for example. I'm going to make a new one called 1D. And in this case, I'm just going to show you NumPy range, not range, array. And I'm just going to click, okay, let me just do, you know, a range from 0 to 3. Okay. And let me go and split this up. And we'll do, we'll print this out, right, just to kind of show you what this looks like. And you can see here, that's my single array. And I also can print something called the shape. And this will tell me basically how many elements are there in here. So when I do a dot shape, you can see here, I have this 3, okay? And basically it's saying, oh, there's 3 elements. So I should probably print this out again. Okay, you can see right here, this is my array, and it's 3 elements in here. And you'll notice that this is a tuple. So basically it's saying, hey, like this is why there's this little comma here. It's basically saying, hey, this is a tuple, just not the number 3. That way you kind of tell the difference. But basically say, oh, this first dimension, this first level of the array has 3 elements in it, okay? So going a little bit into our 2D array here, and I'll print out our 2D array. Okay, when you print this out, remember, this is a whole big guy right here, and then in each part is our elements. So it has a shape where basically the first layer in there is like, oh, there's 3 rows or 3 arrays. And then each of those arrays have 3 elements in here. So maybe another way I could have written this out just to kind of show you guys something a little different. So you can see there's only 2 1D arrays, okay? And each one of those 1D arrays has that. You can see here, this is my 2D array. And so there are 2 1D arrays, basically 2 rows. And then in each one of those 1D arrays, there are 3 elements. Okay, does that make sense? Okay, cool. One thing you might want to ask now, which, you know, depending how you're feeling so far, is that can we make, and make an array with multiple elements. So for example, I have like 1, 2, 3, okay? And I think I kind of showed you guys a little bit, like this is a 2D array, right? And hopefully this isn't too hard to see, but you can see now, I can create this 2D. We saw, for example, we had like, you know, 4, 5, 6. You might say, well, can I do this? Because can you make this as a list? Yeah, we can make a list of lists like this, right? So just to kind of show you a little bit. I can make a list like this and it'll be fine, okay? But if I try doing a NumPy array, you'll notice that that won't work. in that way. You'll see that's kind of a weird thing. It's a list in this case. It won't do an array like you did normally. And you can see there's this data type object. So there's some weird stuff. So note that you can do this stuff, but because the way NumPy works is that in order to make an array of arrays, they have to be the same number of elements. Okay, so in this case, you can see each array has the same number of elements. Okay, and this is actually really similar to what you'll see like in pandas. You know, in pandas, every row, every row has to have something in that column. Okay, and that's kind of what's coming out from this point. All right, so I just wanted to show you guys that kind of like, okay, can you put a different number of elements? Well, kind of, but it won't be an array of arrays anymore. Okay, so again, I have my 2D array. In this case, it has the number of elements, there are 2 elements, and each of those elements are an array of 3 elements. Okay, does that make sense to everyone? Thumbs up, thumbs down, sideways. Okay, cool, sound good. All right, so hopefully this will make sense now for our 3D array. So our 3D array, we're gonna do some predictions here. We have this whole big 3D array, okay? And each one of those 3D arrays, we have a 2D array, okay? And each of those 2D arrays, we have an array of 3 elements. So does anyone make a prediction of what this dot shape will be?
3, 3, 3.
Oops, yeah, you're right. And I also ran it by accident, but yeah. Basically, it's, okay, each one of these parts is a 3 elements in here, okay? If I had taken off, let's say this guy right here, and I'm making it so it's all the same shape. Okay, you can see this right here. So in this case, I have this part. Does anyone have a guess what this dimensional shape will be? So kind of put this here.
3, 2, 2.
3, 2. Okay. So we have, in this case, we have 3 elements. Okay. So we have this 2D array, this 2D array, this 2D array. So that's our 3. Then we have in each one of those 2D arrays, we have 2 rows. Okay.
Yeah, sorry, that'll be 3, 3, 3, 2, 3.
Yeah, I saw it, right? So yeah, you can see there's 2 rows, which is where that 2 is. And then in each of those 1D arrays, we have 3 elements. This should be 3 here. Okay, so if I run this now, run it down here with this dot shape, we'll see 3, 2, 3. And you can see that's what pops up here. Okay. And again, we could go further and further. You can see if we had, like, for example, if we had, let's say, here, we'll do it real quick since we have a little time right now. So I want to really hone in this point because this is something that's going to end up being really important. So if I do an np.array of, let's say, a list of R3D, okay? So now I'm basically saying each element in this list or in this array will be a 3D array. And you can see I have, in this case, 4 3D arrays, right? Is that right? No, 5 3D arrays. So I'll just call this, B. And we can see now if I do a B now, let's do print B because it's easier to read. You can see, it's big, right? But you can see each one of these elements is a 3D array. So this is our first 3D array, our second 3D array, first, second, third, fourth, fifth, okay? So if I do this dot shape here, it'll be the same thing as this 3D array, but there's going to be 5 of them. So it's going to be, in this case, our 5, 3, 2, 3. Okay. So hopefully that's kind of got you, and you can see how you can generalize this as big as you want, right? So just know that obviously these shapes can get really, really large. So we're not going to do more than that, but hopefully that gives you the idea of shape. Cool. Sound good? Yeah. Okay. And I think as you kind of get more practice, it'll also make more sense. Sorry, guys. I don't want to show you all those parts first. I don't know why this showed up. So let's go run all above just to make sure there's nothing weird. Okay, so now we're going to use some built-in functions. So I showed you how to make a NumPy array using like a list, but now we can actually use some of these other stuff too. For example, we have this zeros 3D, And so you'll see me also use this word like matrix. Who's seen a matrix before, or who knows that term matrix? Thumbs up if you know what I'm talking about. Okay. If you don't know what I'm talking about, a matrix, all it is basically, depending on like, you know, how you've learned this exactly, but is usually considered a two-dimensional array. Oops. Did I not have this? Sorry. Oh, I made a mistake here. That's why. Sorry, everyone. There we go. I want this guy. That's a matrix right here. It's a two-dimensional object. So we call this basically rows by columns. There are 2 rows, 3 columns. This is a 2x3 matrix. Or if you did like the dot shape, for example, a 2x3 matrix has a shape of 2, 3. Okay, so that's kind of like how you can think of like a matrix. So know that I call it like a 4x5 matrix here. I mean, its shape would be 4, 5. So this will actually create one of all zeros. So this right here is a 3-dimensional array. It's a 3 4x5 matrices. If I wanted to make this a little smaller, if I wanted just a single 4x5 matrix, it's a 4x5 matrix. You can see that there are 4 rows or 4 one-dimensional arrays, and each of those one-dimensional arrays have 5 elements or 5 rows or 5 columns. Okay, so note that I can basically create this 0 matrix. I can create 3 of these, so this is a 3-dimensional matrix of 3 4x5 matrices. Okay, make sense so far? Cool. And you can see here I can do something similar with ones. Is anyone got to guess what ones will do? It shows just a bunch of ones. All right, so pretty simple, right? So if you understand how to do zeros, you should be able to do ones pretty quickly. And this is useful for certain arrays where we want to do some operations very quickly. For example, if we wanted to, you know, add 0 to it, we saw, for example, we can add basically this part, or we'll do more complicated calculations. But know that we can very quickly create an array of ones or an array of zeros. If I put, for example, just 3 here, this will basically create a single one-dimensional array of just ones. Okay, so cool. And then next we have is a full, which is kind of interesting, is that it's the same idea as having a zeros or ones, but in this case I can say whatever number I want. So we saw, we have a 3x4x5 matrix. I filled it with zeros, I filled it with ones, I can fill it with the number 27. You can see, fill it out with the number 27, or I can fill it out with 2. Okay, let's say 2.1. Okay, or this would be fun. You fill it with all a bunch of strings. Okay, so just know they all have to be the same element in that sense. Okay, but I can fill in whatever I want. Okay, so cool. So all my 2s. Okay, and then you can start doing some stuff right here. For example, you can do a full of 5, range 5. So this is kind of like, wait, what's going to happen? So it's easiest just to run it, and you can see here this will create 5 elements. Okay, I'm sorry, not 5 elements. It will create, well, it is taking 5 elements, but this is the dimension right here. And this is what the elements are in here. Okay, so it's kind of useful. It's like, for example, if you had like a list right here, you can very quickly create a full list that comes all the way through. Note this won't work with multiple dimensions, unfortunately. It'd be great if this was true. Like it'd be able to figure this out. It turns out it doesn't have that ability. But you can do it from this, for example. Okay, so kind of useful to basically create a quick like NumPy array from here using a full. All right. So any questions about how I can generate any of these matrices? Hopefully this feels pretty straightforward once you understand what kind of arrays you can make. Essentially, this just allows us to fill it in with extra elements. All right. So that'll move us on to our last part, which is slicing and dicing. And so for slicing and dicing, this is probably the more complicated part for NumPy arrays. So one thing I would say about this, well, okay, we'll just go right into it, is that we have our NumPy, I've put some more randomness in here. Sorry, not some more randomness, some more built-in function. I can do numpy.random.randomInt, okay? And basically what I'm gonna do is I'm gonna create an array that starts at 0, ends at 10, and it's gonna randomly pick between 0 and 10, okay? And it's gonna make a size of 5, 8. So it's gonna be a 5x8 matrix, and it's gonna randomly pick 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, randomly, all integers, okay? So you can see here, I have this array right here, and you can see, oh, it goes 8, there's a 0 here, there's a 9, 3, and it's a 5 by 8 matrix. So there's 5 rows, 8 columns. And if I run this again, you'll see that it's different each time, right? So random. Okay, so that's kind of a useful thing to do. So I made this random matrix right here, and I want to get the very first row. This is very similar to how if I would use it for like a list, is that if I want to get the very first element in this array, in this case, that first element is a row. So you can see here, if I print this out, I get this row right here. If I wanted this element right here, this, I should say this whole element, which is a single array, what number would I have to put right here? If I wanted this guy. I think I saw someone flash some numbers or something like that. So what was that? Maybe not. So what number would I have to put here?
3.
3. Okay, cool. Thank you, Andrew. So I put 3 here. You can see I get that row right there. Okay, so you can kind of think like, okay, when I do this part, I can get that 3. Another one you can do, like I think I showed this to you guys before with list. You can put negative numbers, and that will count from the very bottom. So I can get the last row, for example, right here. Okay, I can also do like -2, which will give me the second to last row. So that should give me 3, 1, 3, 5, 3, 6, 3, whatever. Okay, and then we can actually get multiple rows. So this guy right here, this multiple rows, will actually do from 1 to 3. So in this case, has anyone got an idea what this would give me? Like think back and like how you would do, what's it called, like a list. What would be the very first, I'll tell you right now, it's gonna give me a bunch of arrays, but what would be the very first array that we would see here using this guy? Would it be this one, the third one, the fourth one, or the fifth one? So you can just show me like with your fingers if you guys want to take a guess. Okay, see Ali put 2, cool. All right, awesome, you guys need 2. All right, so let's go ahead and try this out. And this will end on the third one, right? So you can see here, I have second row. Okay, oops, there you go. Second row, and then it gives me the third one. And remember, well, the third row for 3, okay? So it doesn't do that very last part. So I can also do, for example, starting with the second row, with that 1, and then go to the end. And that will actually give me everything except for that very first row here. Okay, cool. And then one thing I didn't kind of show off is I have like, oops, R0. If I do, let's say I get that very first array right here. What do you think this will give me? What number would this give me? If I have another part right here, can you guess? I see Hazel showing me 6. I see 1. Okay, so good. So we do this, you can see it gives me the number 6. And the reason why, I'll put it up here again. Nope. And let's do a print. You can see that this is my first row, or this is my first array, and then this will give me the first element of that array. So this is my first array right here. That's essentially 6142904, and then it gives me the very first element, 0, which will give me 6 right here. If I put the number 1 here, you can see it's going to give me the number 1. Okay. If I put in this case 2, it'll give me the next one, which is 4. Okay, and so on. And you can also start doing slices. For example, give me everything from 2, the second one all the way to the end. Okay. In this case, you notice that it's a full one-dimensional array. Okay. So this is how you can start doing some slices and stuff like this. So again, there's a lot of documentation on like how you can do slices and everything like this. One thing that kind of is interesting, you can start doing things like this, which are very pandas-like. You can see here is that this is basically for the first dimension. This is the second dimension. So this might look really familiar if you do like .lock in pandas. So if you remember, we did, this won't work, but like .lock, we could do things like this where we say, okay, give me the first row and then give me all the columns, okay? That's kind of what's going on with this going right here. That's directly built because it's NumPy. So in this case, we can get like, okay, let me get the first row, but the second element. So in this case, if, where's my R0? There's my R0, okay. So my R0, so I get the first row and then second element, or second column, Okay, so row times column, and I get this part right here. So I get the number 1. So you see here, I'll get just the number 1. Okay, so you can start doing some things like slicing and dicing and stuff like this and trying to figure it out. If I wanted the very last element, the last row in the last element, I could just do -1, -1, which will give me the last row, last column. You can see, shows up right here. Cool, does that make sense? All right, and then no, I can also slice in the first dimension. So for example, this will give me all of the rows, but give me only the last column. In this case, this is a little more advanced, but I figured I'd show you guys, is that this will say, okay, I'm looking at all the rows, but only return the very last column, which will be 41009, which will actually give me an array. So you can see here, it gives me 4109 kind of going through here. So these are, I'm just kind of showing you some ways you can structure. Just for warning, you don't necessarily have to do this in the labs coming up for a section, but this will be very useful when we start doing more, when you start navigating through the data frames, because this essentially, this 2D array right here is a data frame. That's, I mean, I shouldn't say it is a data frame, but that's basically what data frames are modeled after. So you can essentially do these kind of slices and dices with the same kind of thing. The difference is that if you have a data frame, let's say this is like df, you would do df.lock like this, and that would give you this thing, okay? It's the same concept in that way, all right? Any questions about anything I showed on this guy? Okay, feel pretty good right now. All right, and then this last part, you can see here, I can say, okay, go from the row start. So I have this whole array. I say, okay, start at this part. So it's like start at the second row and then 7th column. It's R0. This isn't gonna work out too well. I don't know why I did it this way. Yeah, okay, I'm sorry, it does work because I do have enough elements. Okay, so you can see I have basically from the second row to the 7th. I'm sorry, why did I put row here? I'm sorry guys, I'm reading my stuff. Past Victor is a weirdo, so I don't know what he's doing over here. But you can see I'm getting these different dimensions right here. Is I'm saying, okay, like going from this start to this end. Essentially what I'm doing is R0 going from 2 to 7, okay? And I'm just gonna get everything. You can see I'm getting, that's my very first part. So you can see I get basically, in this case, where am I? There's my full guy. Okay, so you can see this guy right here. I'm going from 7819, okay? And then getting all of those columns, okay? I don't know why I put 7 here. That's what's throwing me off. See, past Victor is weird. I don't know what he was doing. But let's just put like 4 here, okay? So essentially what I'm doing here is saying, okay, get me all of this stuff right here, 2 to 4, okay, like this. And then say, all right, give me the columns 3 to 6, which will be 0, 1, 2, 3, and then to 6, right? So these guys right here. I can't really highlight it, but 9, 5, 2, and 5, 3, 6. Okay, and that's essentially what I'm doing right here. Okay, so this is some way you can kind of like go through the matrix and grab certain values and stuff like this. And this can be useful when we actually start doing more with our, when we use NumPy to organize our values and everything like that. All right, so any questions at all on this stuff? Okay, thumbs up, thumbs down, sideways. Hopefully I felt like I kind of explained quite a bit of this guy. Okay, I see some people, maybe some sideways, maybe some practice, yeah. Okay, and know that this does take some time. This will only help you in the end to help with data frames. And then a lot of times, because data frames can be converted into NumPy, is that when we start doing some more predictive modeling and stuff like that, we'll be able to deal with this. And I'm realizing in these moments right now, I did have more planned for you guys, but I'm really thrown off right now because I had, sorry everyone. So kind of going a little bit is section 9 is NumPy, but then also doing probability. And I had a lesson put in there, but somehow I think it got deleted and I have to kind of double check of like what's going on with that.